Okay, so example on page 3. So we're going to graph this inequality. We're going to do our two scenarios. First one where x is 0, y is 0. On the second one, we're going to change this to an equation so that we don't have to worry about the inequality sign. Or we're going to treat it like an equation, but we're not changing the actual inequality. It's just for work purposes. Plug in 0 for x on this first one, so 3 times 0 plus 2y equals 6. My 3 times 0 cancels. We're solving for y here. So divide by 2. My y is equal to 3. And so I can put this into an ordered pair. 0, 3. That's going to be my y-intercept. And if I go too fast, guys, please let me know and I can rephrase, reword, rework, anything you need. Okay, second set, we're going to plug in 0 for y, so 3x plus 2 times 0 equals 6. Makes it easy, that one cancels out. I'm left with 3x equals 6. Divide by 3. My x is equal to 2. And so from these 2 points, I can create another ordered pair. And if you want to go ahead and think ahead, what is our line going to be? Solid. Very good. So let's plot these points. We got 0, 3, and 2, 0. So my y-intercept, I'm going to go up to 3. That's 0, 3. And then 2, 0 would be right here. And since we know this is a solid line, we can take our straight edge. Connect. And then the last thing that we need to do for step 4 is pick a test point. Now, always ask yourself, is the origin open that I can test this with? Okay, as long as your line doesn't go through the origin, you can use that as a test point. So, my test point is 0, 0. I'm going to take my inequality, plug in these two x and y values, and see if my inequality is true or false. And so what we get is 0 is less than or equal to 6. Say it again? Well, if you didn't do a test point, how do you know whether to shade above or below? Huh? No. No, our origin has been our test point. So if you look at the last two examples, the one from our foldable, this is one from our foldable, why did we shade this? Because our test point satisfied the equation. It made it true. But look at the last example. Okay? Did our test point satisfy the equation? No, so we shaded the other way. So, well, right now we're in standard form. There is another method, but we haven't learned about slope-intercept form. So you probably are talking about slope-intercept form, and that is different. Right now, up to section 7.2, we've only covered standard form. So all of your homework is going to be in that form. That's why I'm going over it this way. Okay, so our test point, 0, 0, we did say that it satisfied the equation. So what area are we going to shade? The top portion? Yeah, we're going to shade the bottom because we need to make sure that 0, 0 is included in that point, or in that area. So for these that are in standard form, guys, you can't just look at the equation and determine it. You've got to do the test point to see what side you're going to shade. That's the difference between slope-intercept and standard form, is that you can't just look at this sign. Just because this is less than doesn't mean it's going to be below, because over here we had a less than on our little foldable, but what did we shade? Above. So you've got to do the test point on this section in order to determine top or bottom. Now, we will eventually get to inequalities in slope-intercept form, but for right now, this entire 7.2 is in standard form. So that's why I'm going over it this way. Yes, ma'am.